All right, so we had our little chart last time. I need to bring up the keynote for this class. All right, so we have our different rooms, and have we actually created the objects for all the rooms yet? So yeah, so there's S120, there's CS Hallway, there's S118, there's the Mac Lab, and then we need to add those. So we went ahead and we added our player to S120. So the one person is going to be sitting here in S120 to begin with, and then we went ahead and added to the north here the CS Hallway. And how are we storing that? We're storing it inside of a dictionary, right? A dictionary is going to be in this case, it's going to be a string. It's going to be the name of it. And then its destination is going to be another room object. So no longer are we storing, the kinds of values we're storing in the dictionary isn't just either strings or numbers. Now we're storing objects, and specifically in this case, room objects. We also have a collection of players which are in a room, right? So a room contains a number of players. For right now, it's going to be just us because we're not multiplayer yet. And then we have a collection of destinations, which are going to be name-value pairs, where the name is a string and the value will be a room that is a destination. When we add a room, give it a direction, we set that dictionary at bucket direction equal to the room that it goes to. All right, so and then same thing with players. We just append that to our list of players that are in there. We currently don't have the ability to remove a player from a room. We're going to have to write that here in a few minutes because when we move from this room to the CS hallway, we'll have to remove ourselves from the current room and add ourselves to the destination room. Does that make sense? And then redisplay the situation to us. Okay, so let's go ahead and we've added our player to S120. In fact, actually, I'm going to add the player last. That way we could just map our rooms first. All right, so we have S120. We added the north exit. Then we're going to have CS hallway dot add room. We're going to have a south exit, which is going to lead to S120. Then we're going to have a CS hallway dot add room. We're going to have a north exit, which is going to lead to Mac Lab. We'll have CS hallway dot add room. We're going to have a west exit, which is going to lead to S118. Okay. Then S118 dot add room has an east exit, which is going to lead to CS hallway. And then Mac Lab add room will have a south exit, which will lead to CS hallway. All right, so that should hook up all our rooms. That look right to us. Did I leave anything out? I think I got all the stuff. All right, then we'll go ahead and add our player to S120. We'll go ahead and display it. So to test this, we'll see now S120 has a exit to the north. So let's open up the terminal here. Whoop. Actually, is it on my desktop or is it? No, it must be on the desktop. Okay, so now we're in S120. Littman Classroom also here is actually just us. there's us who's standing here. So let's add them. Instead of S120, let's add them to CS hallway. And this guy should show 3 different destinations, right? South, north, and west. If we happen to be added to that room. Row. We shouldn't have to. Well, we're already printing it out. Yeah, we're adding that player to CS hallway. And when I ran this, it still shows S120.
Because you said S120 display.
Oh, that does make a lot of sense. So here. We see that we're not in that room anymore because we were never added to that room. So that actually does make quite a bit of sense. So now we'll go to CS hallway, which should show the 3 exits. It should show us in that room. All right, so here's a boring hallway. We're not displaying exits yet. Was that part? Yeah, so we need to add that. Was that part of the assignment?
Yes.
Okay. So let's go ahead and show the exits, but at least we're in the right room now. We see ourselves added there. So as part of the display now, we need to go ahead and show, usually it's going to show valid exits first in a MUD, but it doesn't really matter. So let's say print.
All right. Well, there you go. Well,
Possible exits.
thank you.
And we'll say for exit in self.destinations. We'll print out exit. So there's our possible exits, south, north, and west for that guy. Notice that these are not in any particular order. All right. In terms of either alphabetized or anything like that. And that's one kind of thing about dictionaries, is dictionaries do not promise order. So I think we'll probably always get them out in that order because of the way they were originally put in. But a dictionary does not promise you the order in which stuff will come out if you iterate over it. So if we wanted, let's just assume, let's do a couple of things here. Let's say that we wanted to show the possible exits in alphabetical order. How might you go about this based on what you know so far? And you are allowed to use the built-in sort function this time. Because we wrote several sorting algorithms, right? You know, we sorted strings, or did we just sort numbers? I think we sorted strings once. So I want to print these out, south, north, and west in sorted order. And I'm telling you, a dictionary does not give you a promise as to what order they come out in. So how would we guarantee that they're sorted? And really, ideally, I want them to be on one line instead of taking up all this space going straight down. So using the current tools that are in your toolbox, how might we pull this off? Let's start off with getting them all shown on one line. Let's just go with that route. Forget about putting them in a certain order. Just they all should be on one line. Go ahead.
You could put give it the return exit concatenated with exit and then print that after.
Okay, so we could build up a string. All right, so we could do something like exit string starts off as the empty string, and then as we're going through here, and you said return, but we're going to end up printing it, so we're going to be building up a string. So we'll say exit string is going to equal whatever exit string currently equals, concatenated with, let's concatenate it with the current exit. And then I'm going to go ahead and I'm going to also concatenate it with a space. Put an extra little space on the end of it. That way they're separated by spaces. And then after this for loop, I'll go ahead and print out exit string. That make sense? Run that guy. So there's our south northwest. Similar to what we had before, but now it's all on one line. Okay, so now we got it all on one line, but I also want it sorted now. How are we going to pull that off? So this is all about string manipulation. So we whipped through our dictionary here, grabbed all of these are what are called the keys. So the exit will be the key of each dictionary. The value at each of those keys we know is going to be a room object. All right, so we're going to just go through every key inside of our destinations dictionary, and we're going to concatenate that key onto a kind of a running string and just build up that string. So that's one way we can get it all on one line. But what if I said now I want it to be alphabetical order? What do we know how to sort at this point? Whether we're using the built-in sort function or we're using one of the sorts we wrote. What kind of format does our data need to initially be in order for us to sort it? Yo. Well, numbers are possible. Okay. Keep going with it. You say you might have said something else intelligent there at the end.
I don't think I did.
You know, you're pretty sure no. So no, yo. Okay. We know how to sort numbers. We can know how to sort strings, but they need to be in a certain format. What format do I need to have them in before I can actually sort them? A list. Yeah, we need them in a list. Because sorting a string, I mean, we probably could pull it off if we wrote something new and we decide that's what we have it in, and we need to sort that. But that's not what we know how to do at this point. So if we can get these guys into a list, that would be beneficial, wouldn't it? All right. So instead of building up a string, could we build up a list? So could we say how would I do that? How would I build up a list instead of build up a string?
I do the brackets.
Brackets where?
Make exit string.
Okay, so maybe call this guy exit list instead of exit string, just so it's meaningful. And then you want to do that. Okay, so now it's an empty list. It's an empty list to start off with. Okay, what do we do with that empty list? This no longer works, right? So what do I have to do? How do I load each exit into that list? So append it. So the list we're appending to is called exit list. Dot append. And then what are we appending to it? We're appending exit. All right. Then down here, I could just print out exit list because that already shows us kind of a nice little format with the little brackets around it. So there's our south northwest. So showing us our stuff in a list. All right. Now, how do we sort a list? What is the, is it sort exit list like that? Is that the built-in sort function? Or is it exit list.sort? All right, so exit list.sort returns the sorted version of that list, I'm guessing. Ooh, into method sort. Okay, we were close. It's a function. So we can say exit list dot sort. That'll sort it, and then we can print out exit list. Yep. So load everything. Start with an empty list. Load all our exits into a list. Sort that list. That sorts it in memory, so now it's permanently sorted from this point forward. And then print out that exit list that shows us our exits. I'm not sure how necessary that was, but it kind of took us through an exercise of doing some stuff that might be handy in other applications. Okay, any questions about how we just pulled that off? We had to go look at the documentation to see what the built-in sort function was, and but we all know how to write insertion sort, and we also wrote a merge sort, right? That was a fun one. Okay, so we know how to write some sorts, but if there's one built in and we have access to it, maybe we just use that instead of writing our own sometimes. Okay. Having said that, when might you want to write your own sort?
If you want it sorted in a specific way.
Okay, well, tell me more about that. Okay, so let's say that we wanted to sort rooms, room objects. So it seems like this built-in sort probably knows how to sort kind of your primitive stuff. It knows how to sort numbers, seems to know how to sort strings, stuff that's directly sortable, right? Now, we invented the concept of a room here, right? When we named it a room. We also invented players and stuff like that. So what if we wanted to sort a room maybe on the number of exits the room has, from smallest number of exits to largest number of exits, something like that? Is that something that's pretty unlikely that the built-in sort function is going to know that's what we mean when we say we wanted to sort two rooms? That's what we mean. We want to compare it on the number of exits? It's probably not built in, right? So with a situation like that, we might be stuck writing our own sort to pull that off. What a lot of languages do, and it's entirely possible Python does this as well. I haven't done it with Python before, but kind of a common way of solving this problem in a language like Java, they have something called a comparator, where instead of having to re-implement the wheel, instead of creating a brand new sort, what you do is you use the built-in sort, but you pass it kind of the information about how you want to compare the objects. So you create this comparator object that says, I want you to compare the number of destinations to the number of destinations. So you kind of teach it what you're comparing. They give you a little mechanism for doing that. So you are having to do something custom, but you don't have to rewrite the sorting logic. Because whether we're sorting the number of exits, or we're sorting the alphabetical version of the names, or we're sorting a bunch of numbers, the sort itself is the same algorithm. Just the values we're comparing within the sort are what change, correct? I mean, sorting is sorting, regardless of how of what we're sorting. We just need to give it some information about how we want it to actually organize, in that case, our rooms. But that's kind of something that doesn't make a whole lot of sense for us. We don't need to sort the rooms. But if we did want to, that's when you might have to go in to start doing a more custom implementation for your own sort. So it's not a complete waste of time that we learned how sorting works, is I guess what I'm getting at there. Okay, so right now, a room knows how to display itself. And I guess just for completeness here, let's check the other rooms. So we'll go to MacLab, make sure this shows us one exit to the south. Yep, so there's our MacLab. And then we'll go to S118, and this should show one exit to the east. All right, so we have our department mapped out here, it seems like. Now, what would be nice is for us to be able to traverse through the room. Okay, now, right now we kind of have a bunch of individual pieces that are all kind of disconnected. So let's go back to our picture here before we get kind of too deep in theory. So here's all of our rooms, and these guys are all connected to each other. Okay, now what we're going to do is I'm going to throw our player out here. All right, so this is our player. Now, what we're doing right now is we're adding a player to a room, which we need to have happen, right? A room needs to know what players are currently in the room, including ourselves, right? But when we want to walk through the computer science department in real life. So this kind of goes back to this concept as we're kind of planning out this application. This goes back to the concept that our modern programming languages are built with the intention of letting us solve problems the way we already solve problems. Okay? So if we're standing in this room, how do we get to the next room? Do we ask the room to teleport us over there? That would be kind of cool. They actually did that if you saw the movie Spaceballs. Anybody seen that movie? Yeah, he teleported from one room to another, and the teleporter was on the fritz, so they put him on backwards, and then, so he was complaining his butt was too big and that kind of stuff. So, and then he finally gave up on the teleporter, just walked right next door where he was trying to teleport over. But it maybe someday. But right now, the way we solve problems in real life is we would not say to the cloud, teleport me to the CS hallway. We wouldn't ask the room to move us there. We would decide to move from this room to that room. And then if we kind of break that down into the baby steps, what does that mean we need to do? It means we need to, you could choose the order, because at some point in time we're going to be in both rooms at the same time. But ultimately we need to remove ourselves from this room and add ourselves to that room. Right? And we're going to take one of the exits. So a player, how many of you know what room you're in right now? We all do. You might have forgotten the room number. This is S120. But we are all, as players in this world, we are all aware of the room we currently inhabit. Correct? And if we give the room its little brain that we seem to have given here, it's also aware of us. If these walls could talk, they would say, okay, we got a whole bunch of players in here. Its list of players is large, and it has one exit related to CS, even though we technically have two doors. All right. So the room itself knows who's in here. But we know as individuals the room we're in. So we can ask the room to remove us. We can ask the room to hand us the room that is the destination to the north. So I can say, give me the destination to the north, because that's where I want to go. Now remove myself from the current room I'm in. Add myself to the new room. And what we can do is, as part of that mechanic of adding to a room, the room can then let the player know about the room they're currently in. All right? So let's just think about that one mechanic. When a player gets added to a room, how does the room let the player know about the room they're currently in? When you walked in the door, you looked around and you kind of recognized, I'm in S120, right? As if the room told you that. That's kind of the loose connection we need to make here. Now, would you agree? Well, let's go back to player real quick. So right now, here's the things a player keeps track of. It knows its name, it keeps track of a bunch of dice and some hit points. Now, we want a player to also know about the room it's currently sitting in. Okay? Now, when a player is first born, they're not in any room, are they? Okay? So if we wanted to give it a value, we can say self current room maybe is equal to none. That's that default value. In other languages, it's called null, N-U-L-L. Some languages, it's called nil, N-I-L. So none means nothing. It's like a default value of nothing. All right? So we'll go ahead, and as a player that was just born, this is a constructor for a player, before anything else happens, I don't have a room. If I were to ask myself, what current room am I in, it's nothing. Okay? That's a problem. But we can check that value and know that we shouldn't spit out the room we're in if it's nothing. All right? So what I'm going to do here in player is we're going to go ahead and we're going to say def look. Okay, so the idea would be when we're in a room, it's the player that looks around, right? In fact, let's make it a little more explicit. We're going to look around. And what does look around say we should do? It says we should ask the room we're currently in to display itself. Does that make sense? Our rooms know how to display themselves right now. But we need to be the one to ask the room to display itself so that it can always show us the room we're currently in. So that we don't have to keep playing this game where we just add ourselves to different rooms and then tell that room to display itself, proving that the exits are where they need to be. All right, so do you see how we're kind of trying to get into this virtual world, if you will, that we've created here in this text-based dungeon crawler thing? All right, so a player knows about the room that they're currently in. They can then ask the question, if the room I'm in is not equal to none, then ask the room I'm in to go ahead and display itself. Otherwise, maybe we say, I don't know, if we're not in a room, what should we print out? Huh? We're dead. I mean, we're in the ether. Ether. Okay. So we'll ask the question: if self.current room is equal to none, that's the current situation. We'll go ahead and print out in the ether. Did I spell that right? Is there an A? So 1A or 3 A's?
You're good.
Oh, I gotcha. This guy.
Yeah.
Same thing.
It literally is the same thing though.
All right. We'll go with 4 E's and call it good. All right. Yo. We'll call it good, yo. All right. So now we're in the else here. Otherwise, if we actually are in a current room, we're going to ask that room to display itself. So we'll say self.currentroom.display because we know that'll be a room object. Okay. Now at this point, we've given this ability. Okay, a player, we've said you now know how to be aware of the room that you're in. We're capable of being aware of the room we're in. But at no point in time have we actually done anything about setting the room we're currently in to anything other than none. When I was first born, when I was initialized, when I was instantiated, kind of synonyms, okay, I just set my current room to none, which is always going to put me in the ether here, right? So let's start with that. Make sure that that this little Boolean expression here is testing true because we started it off at none right here, and we never changed it otherwise. So let's not have a room display itself. Instead, we're going to say p1.lookaround. So we'll ask the player to go ahead and look around. We've mapped out our whole department at this point, but when the player goes and looks around, they're in the ether. That's what it should say, because we never actually added them. Even though we added the player to this room, that room never let the player know that he's now in that room. You know, we know that's what we want to ultimately do, but we haven't written the code to do that yet. So right now, this player should be in the ether. So there's the in the ether. All right. Now what we want to do is we want to change the way add player works so that it lets the player that's being added know about the room it's being added to. Okay, so we're about to test our understanding of a concept that I mentioned was very important. So we're in room. Here's our add player. So we are adding that player to our players array. Now I also want to let the player know about the room it just entered, or he just entered, or she just entered, whatever. How do I do that? We are inside of the class room. So when this guy gets called, I'm either S120, or I'm S118, or I'm the CS hallway, or I'm the Mac lab. I'm one of those 4 rooms in our world right now. Okay? So assuming we were just added to S120, I've gone ahead, if I pretend I'm S120 for a minute, I'm the room object, I've gone ahead and I've added the player that was just put into my list of players. But now I need to let that player know that he's now in my room. How do I do that? No, I don't want to show him what room he's in. I want him to know what room he's in. I want his current room variable, the guy we wrote here a few minutes ago. I want that to no longer be none. I want it to be the S120 or the S118 or the CS hallway or the Mac lab. I need to let that player know what room he's currently in so that when that player goes and looks around and he notices that he's in an actual room, he'll tell that room to display itself. But that player needs to know about the room first. So we assume you just walked in, okay, and I'm the room. So I'm the room object. You've walked into the room. I've gone ahead and I've added you to my list of players. How do I let you know now? How do I set your current room variable to know that you're currently in S120? I'm S120. What do you think? How does an object refer to itself from within itself? If we're calling add player, if my version of add player has been called, and I've said I'm S120, right? Okay, I'm S120, my version of add player has been called. How do I refer to myself? How does an object refer to itself from within itself? Self. Now we're saying the answer a whole lot, right? Self. So if I want you to know about the room you just entered, I want to set your current room equal to self. All right? Player dot current room is equal to self. Does that make sense? Now remember, in this case, if we kind of go down here and play this out, I'm going to go ahead and I'll add this player to S120 just so we're duplicating what we're saying in real life. We've mapped all our rooms. I went ahead, we'll say you're player one. We've added you, P1 into S120. So I'm playing the role of S120 in this this play. Then you go to look around. Because when I added you to the room, I let you know about me. I said, you are now in S120, just so you know. And you set your internal variable called current room equal to that. So now when you go to look around, that's this guy right here. When you go to look around, you'll notice that you're no longer in the ether. Your value is something other than none now because I set it. I let you know about me. So you'll actually print out whatever your current room is, which is a pointer to me right now. And you'll tell that to display. Okay? So let's see it work first. So there you are in S120. Does that make sense? Now these are all pointers. S120 we have one variable here called S120. This guy right here. We have another variable called CS hallway. So S120, that one variable, is currently being held by a whole bunch of different objects. Remember, it's just a place up here in memory. And we're passing it around by value. We're passing pointers to everybody. So who currently knows the memory address of S120 in our model right now? So if we think of everything we have on the screen here as actors in our play, who currently knows about S120? Okay, player one. P1 knows about S120 because we set your current room. Okay. Who else knows about S120? Who else has a pointer link to S120?
CS hallway.
CS hallway has a south link to S120. Same memory address. So you have, in your pocket on a piece of paper written down the memory address of S120. Okay? If we assume he's CS hallway, in your pocket you have a piece of paper. It's a dictionary. Actually, you spent a little bit more money, right? You just literally have a Post-it. He has kind of a portfolio type thing, or Rolodex, if you will, where he sees that, to the south, I have a pointer to S120. Okay, anybody else? In the big scheme of things, that's kind of it. We also have a local variable here that knows about S120, but, in terms of our players and our object-oriented scene here, CS Hallway knows about S120. You know about S120. Those are not two separate S120s. Okay? They're the same thing. If we're standing in the CS hallway and we're peering through that door, we see the same room that that you're sitting in. Right? This room didn't exist multiple times. All right. So that's the advantage of pointers, because now we're starting to work with objects, even though it's just text at this point, it feels heavier, right? This isn't just the number 7 or the string hello. Now it's a whole room that has stuff in it and has abilities. That guy must weigh something, right? So it would probably not be in our best interest for us to be passing that room around by value. Okay, this goes back to that old concept of pass by value versus pass by reference that we talked about way back when we talked about the weaknesses of C++, where it empowers the programmer to make that poor decision. Do I give somebody my house, or do they give them the address of where they can find my house? And we decided in real life it would always make sense to give them the address. Okay? Now, if we did make a duplicate, if CS Hallway got a copy of S120 and you got a copy of S120, CS Hallway, when he looked in here, he wouldn't see you. Different S120. You're in your own version of S120. Okay? He has his own version of S120 and they're not linked. That's not what we want. We want these guys to all exist one time, and we'll just pass around pointers so we have little wires connecting these things. Does that make sense? All right. And again, I think are we starting to see the point of why we need to draw pictures? Okay, so if we kind of come back here, our player has a link to S120, and CS Hallway has a link to S120. Two separate guys both point to the same single place. That makes sense? Now, what we'd like to do is we would like this player to be able to leave a room. We want this player to be able to leave a room and enter another room. So now we need to teach a room how to remove a player. Because two things have to happen when a player leaves a room. What has to happen? Because right now, doesn't this room also know about that player? Yeah, you've been added to the players list. Okay, so the room, I'm S120, I have a collection of players and you're on the list. Okay? Now technically, if we wrote this, I guess in a bad way, let's say, we could have you go into CS Hallway and never remove you from this room, and then they both are kind of laying claim to you. Right? Okay, because high-speed cloning. Okay, but it's not a clone. It's the same guy. You are literally in two places at once. All right, and you can imagine that could get dangerous pretty quickly in terms of logic. Right? Nobody's getting hurt over it in this case, but that would be a problem. So what we need to do is we want this guy to forget about you. We want this guy to then know about you. So to move you from one room to another, we need the room that you're currently in to forget about you, and the room that you want to go into to learn about you. And then for you to set yourself up for you to be aware of that room. Okay? So, what we're going to do is we're going to teach a room how to remove a player. We're keeping it simple. We're not going to implement that whole little logic thing we just discussed. We just want to teach a room. Here's a player I would like you to remove. Go and find him in your players and remove him. Does that make sense? That's all we want to do. We want to find them and then we want to remove them. Okay. Remove player, taking a self, taking a player. How do we delete something from a list? Is it D-E-L?
Yeah.
This is in the room class. We're teaching a room how to remove a player. Oh man, this is even easier than it should have been. So remove the first element in the list whose value is X. I don't even have to go through and find them. I can just remove the object. It'll search for me. Yeah, that's great. Is there a... All right. Because, well, let's see. All right, let's just do it this way. So to remove a player, we're going to say self dot the players dot, what was it, just remove? Dot remove player. That will remove that player from that list. Okay, let's just go through the mechanics of this. Okay, so what we'll also do is we're going to tell that player that his current room is now none. He's currently in the ether, right? So we'll say player dot current room is equal to none. So after I removed you from me, now I'm letting you know you're no longer in the room. Okay? So we're in S120. We looked around. Then we'll say S120 dot remove player. What player? P1. And then we'll say CS hallway dot add player P1. Then P1 dot look around. So we entered S120, we looked around. Then we asked S120 to remove us. And actually, let's go ahead and look around again after we've been removed, but before we've been added to the new rooms, and we should be in the ether. Then we enter into CS hallway and we look around again. Okay, so here's S120. Then we get removed, so we're in the ether. And now we're in the CS hallway. Make sense? Now, for your homework, similar to what we did for our fighting game, where you got to choose whether you wanted to heal or attack, heal or melee, whatever we called it. We're going to have a player. The player's going to have a menu where you can type in the direction you want to move. So if I were to type in north, it will remove me from this room and add me to that room. So I should be able to, when you're done with this, I should be able to walk through the whole department. Does that make sense? So after I make a move, it should have me look around. So you're going to add that ability to player. Players need to be able to be shown a menu that they can respond to forever. They can just get lost in the department, and they should be able to walk around in the world. Make sense? Okay, I've given you all the pieces to do it. You literally have every single piece. Now you just need to put those puzzle pieces together to solve the problem. All right, I will see everybody on, and I'll give you this code as the starting point. I'll see everybody on Monday.